Hello everyone, good afternoon. Looks like I've got the toughest time slot of the afternoon. Oh, there we go, that's a bit louder. So, before we jump into this, I will just reflect on my past 24 hours in Melbourne. I think we've covered a lot today about the way that standards can be interpreted and how they can conflict with each other and how they can have different meanings and everything like that, and how important it is to read your standard or any source of information correctly. Melbourne got me with this yesterday. I was walking along the street, saw a sign up on the side of the building. It said, #1 toasted sandwiches in Melbourne. I thought, here we go, I don't mind a bit of grilled cheese. Let's have a go at this. Got it, ate it, it was not too bad. Don't know if it was #1. Started feeling not very great about 4 or 5 hours later. Turned out they weren't #1 in taste, they were #1 at making me hug the toilet bowl for the rest of the night. So if I feel a little bit flat today, I'm going to try and turn it up and get us through this in style. Don't need to say much about me anymore. Byron, thank you for that introduction. It was great. I've been in waterproofing my whole life. I enjoy doing it. I enjoy the opportunity of being able to be here and talk to you guys about all this stuff. I find it very interesting. So I hope you enjoy what I'm going to share with you. Okay, so only 2 things today. I'm going to spend 20 minutes on each of them. First part is going to be performance solution development. And then second part, we're going to look at some very interesting stuff around AI and what's essentially going to impact the future of everything we do in construction and design. Performance solutions. Let me share my thoughts on performance solutions, or more so deemed to satisfy provisions. We had a lot of good advice, and I think my co-presenters here might hate me for this one. I hate deemed to satisfy provisions. It's a pretty strong statement, but I'll explain why. Let's use the analogy of a chef, right? When you start out as a chef, you start making very basic things. You follow recipes, maybe you're doing a frozen meal or a cake mix or something like that, right? You're following what someone else says. No self-respecting chef wants to stay at that level, definitely not going to open up a restaurant with frozen meals, so you want to get better, right? And when that chef, what's the natural progression of that chef's life? They start experimenting on their own. They see, they try and they fail. They fail a lot, probably, I did. And they get better at it. And then they start becoming discerning. They know that this ingredient equates to this. If I use these and put these things together, then it's going to get this outcome, until you work your way up, you own your own restaurant and maybe even get a 1 or 3 Michelin stars, right? That's what performance solutions are. Deemed to satisfy tells you not to think about anything and you just follow what you're told. And as the other guys have shown, it's actually not that easy to follow those guides sometimes. Performance solution is for master chefs. It is where you look at the situation and you decide, using everything that you've collected in your life, about whether it's going to work or not. So that's what we're going to talk about. We're going to talk about how can you be less intimidated by performance solutions, because they allow us to do a lot of great stuff. And at the end of the day, satisfying performance requirements is what we have to do. That's the NCC. So, going to do the recap again. I know you've seen this a lot today. Performance requirements under the NCC, it's what we've got to satisfy, right? No more about that one. A little bit of a different looking diagram here. Again, we've got deemed to satisfy down on the right-hand side, which means follow your standard being your evidence of suitability and or expert judgment. Expert judgment part comes in on whether you've actually followed that standard. Left-hand side, performance solution, and we'll go into these in more detail later. You can see that we've got 4 icons over there. Those are our assessment methods, and you effectively validate your performance solution by using a combination of those assessment methods, right? So let's continue, and we'll come back to what those are later. Okay, just a quick one here. This is the ABCB website where you can actually download the NCC. Handy little fact that there is a consolidated performance requirements document. It takes all the fluff out, just shows you what performance requirements are if you find value in having that clarity. Cool. James covered this earlier as well. It's the naming convention. How do you know that you're looking at a performance requirement? It's the 3rd letter. There we go. So in this example here, C1P5 means Section C, Part 1, Performance Requirement Number 5. So anything where the 3rd letter is a P, that's what we're looking for. So a performance requirement then needs a performance solution if we're going that way. And this is just what the ABCB defines as a performance solution. A performance solution provides a tailored solution to meet the intended objective of the performance requirements. Right, makes sense? Okay, next one. How do we create a performance solution then? It's a good question. Sorry about this, guys. I don't know why that's lagging like that. Okay, it's a 4-step process. We're going to go through each of these in detail. Step 1, we're going to prepare a brief that lets everyone know that's involved how we're going to approach this certain issue. Step 2, we're going to analyze the actual design that we're proposing and maybe iterate it and change it if it's not up to scratch. Then we're going to evaluate all of those results, compile them all together, and then finally we are going to prepare the final report. Okay, so step 1 is the design brief. Like I said, this lets everyone know what the performance solution is going to cover. The way this came about, it was actually introduced in NCC 2019 Amendment 1. The reason for this brief is that performance solutions, when they were rarely done, they all looked wildly different. You could have one that was a 2-page document, very simplistic, and then you could have others that are 200 pages with a lot of supporting evidence, right? Our surveyors were in a precarious position. They didn't have a benchmark about, where the standard should be for performance solution justification. So this was introduced, and this document is effectively to let everyone know, but really mainly your PCA, your certifier, your surveyor, what you're going to be doing, what you're trying to achieve. So first one, summary of the proposal, explaining what it is. A description of the explanation of the proposed solution is next. Nominated applicable performance requirements. We covered how to find those already. The agreed analytical assessment process. How are we going to consider this? Next one's quite important. Agreed acceptance criteria. What would this be? Water doesn't come into our building. Right, that's, if we can prove that, then that's the criteria we're looking for. As an example, required scope of supporting evidence. So we'll define what we're going to, when we do the performance solution, what we're actually going to deliver as part of that justification. Format and content of the final report, just a bit of an outline on how you're actually going to compile all this information so it can be digested. And then finally, acceptance of stakeholders. Now, stakeholders is anyone that's involved in the delivery of that. Your builder, your architect, structural engineer, maybe facade engineer, of course your surveyor, your PCA. Okay, so let's do a bit of an example of what might be contained in this. So this is using facade. Facade's actually not my strong suit, but I think it's a handy little example here. Bit of content up here, but I'll run through it. What are the design objectives? Well, it's been identified that the cladding must provide a degree of weatherproofing in order to satisfy the performance requirement, being we don't want water coming into our building. So who should be consulted? We identify that the client, the builder, the testing authority, appropriate regulatory or approval authority, which is our PCA or our surveyor. Next one, what's the basis of the performance solution? Well, why does it have to be a performance solution? There are no DTS provisions. So by default, it is going to be performance-based design. What evidence are we going to use to justify this? Well, fortunately, the NCC actually offers us a verification method. So that's found in FV 1.1 and table FV 1.1. If you apply that verification method and get a positive outcome, then that's how we're going to justify. That's going to be our evidence. Which DTS provision is applicable? In this case, none. We don't have any, unfortunately. And which performance requirement is applicable? So it's going to be FP 1.4 in the old way of doing things. I should have updated that now. It's F3P1. A roof and external wall, including openings around doors and windows, must prevent the penetration of water that would cause blah, 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 harm to the amenity of the building. Okay, this is acceptance of stakeholders. We've covered this already. It's just important to get everyone on board with it before we move into the next stage. And again, this is the whole purpose of the brief. If someone looks at this and says, oh, there's a big gap in here, like I'm not going to be able to fire rate this or whatever the solution is, then it gets knocked on the head or it gets back to the drawing board and reconsidered until everyone that's relevant is actually happy to sign it off. Oh, okay. that's step one. Step 2 out of 4. So just our clause out of our NCC here, a performance solution must be shown to comply with relevant performance requirements through one or a combination of the following assessment methods. We'll get into those in a second. That was the 4 we touched on before. I've got the photo of this guy up here. This is a lawyer. He's leaning over to the jury. He's giving them some evidence, right? That's how you've got to look at these documents. We are, the person writing it is the lawyer. You're making a prosecution or a defense case. You're putting forward the evidence in a cohesive way, and you're trying to win over whoever might read this document for certification purposes or any other reason in the future. Okay. Our first assessment method, evidence of suitability. This is lab testing or any sort of testing that can be prepared earlier. We had XTechGen up here previously. We've got a nice photo of a guy doing some sort of laboratory testing here. He's going to compile a report. That report can then be used as evidence of suitability if it's relevant to what you're trying to achieve, say the impermeability of a membrane or a facade system or something like that. So this is pre-prepared documentation. I think it was Stan mentioned before, code mark certificates. On that note, I see a lot of people using code mark as, here's our performance solution, it's a code mark certificate. That's not true, that's not how code mark works, but code mark is excellent evidence of suitability because it applies a method and then it checks that the outcome has been achieved. You still need to do a performance solution, but code mark makes it a hell of a lot easier because they have such great evidence of suitability. Next one, verification method. So we talked about this. This is the FV 1.1. What we effectively have here is a mock-up, a prototype of a facade system. This is all well controlled, the amount of water, the amount of wind pressure we're applying against it. You follow this method that tells you how we're going to test out this prototype. And quite simply, if under these conditions, specific conditions, water is able to come in, it fails. If water is kept out, then it's a pass. So nice and simple there. There are a whole lot of verification methods. This one is mentioned in the NCC, but you don't actually have to use one that's mentioned in the NCC. It just has to make sense for the scenario. C, expert judgment. We've got a guy up here. He looks like he's been around the industry for a while, probably seen a few things, compiled all of this knowledge of what works and what doesn't work inside his head, and he's going to make a judgment on whether the proposed solution will or won't work. Quick point on this one. I would never suggest writing a performance solution with only expert judgment. You should always use expert judgment in conjunction with one of the others. Reason behind this is all you need to knock it over is another alternate judgment or opinion from someone else. So the way expert judgment should be used is a method of interpreting, okay, is our verification method applied correctly? Is our evidence of suitability relevant? Are we, the very next one is comparison to DTS. Is our solution suitably comparable to a DTS provision? So this up here is actually from AS 465 4.2. I don't see this built very much, to be honest. It's double brick. We've got a suspended concrete slab through there. I don't know if I've ever seen that built like that, to be honest. So as far as DTS goes, this is not very useful to us, but we do build things quite similar to this. We have upturns, we have cavity protection. We see, using a combination of expert judgment, you can say, well, okay, we've actually got a precast wall here, and we have a suspended slab interfacing with it, and we're going to apply our waterproofing upturn, and then we're going to have a high-build elastomeric paint over that and get continuity of the protection. We're not doing this, but we are doing something that's going to be equivalent performance, and that's how we're justifying our performance there. So those are our 4 assessment methods that you have at your disposal to justify how you're going to perform. So then after all those things, we've got this little flow chart here. It's pretty simple. This is just carrying out analysis. Pretty much what it says is do whatever you're doing, apply a test method, research the documentation. If it doesn't work, then go back and rethink it again. Maybe you need some more elements in there or move things around a little bit. Then apply the process again. We get a good outcome we're happy with, being we're keeping water out of the building most of the time, then yes, we move on. And by move on, I mean step 3. So step 3 is evaluation of results. I know this can sound very similar to analysis, What this is compiling everything together. Often you will have a lot of different supporting evidence doing different things. You might need a additive for concrete for a certain purpose, and then you need an upturn over here. Most performance solutions won't just be one element. They'll have a lot of things going on, and you need to compile it all together. I've got some examples at the end of this, which we can talk about, and I'll explain that a bit further. That's pretty easy. Then finally, we prepare the final report. So this is really just compiling everything we've done to date. We've looked at everything, we've considered all the options, we're just putting it together, and we're making it tell a cohesive narrative. I've seen a lot of performance solutions that have been rejected by certifiers, and it wasn't because they didn't have a lot of information. Actually had an abundance, 100 pages of documentation, but it wasn't compiled cohesively, and it didn't tell the story about how those things actually work together to give a level of confidence that the performance requirement's going to be satisfied. So don't fall into that trap. You have to tell the story and explain how it's going to happen. Okay, a couple of examples. I've kept them not overly complex because we don't have too much time here, but I'll explain something about this because it is a little bit of a contentious one. I actually have to write an email later to this effect. This is tile and pedestals used to achieve a flush transition. And I know it's not exactly flush, but bear with me here, just pretend. So in 4654, we have effectively two options for our external waterproofing. At this location here, where you transition between internal and external space, you have to either have an upturn of waterproofing based on wind speed. It's normally about 70 millimeters, give or take, depending on how big the wind speed is, measured from, and this clause says this very specifically, I haven't put it up here, but it says upturn height measured from the external finished floor level. Finished floor level is here, right? It's the finish, it's the surface you walk on, no matter how you look at it. We know where a finished floor level is. And this is the argument I have with a lot of people. Wishful thinking is, oh no, but because water runs down here, this is our finished floor level. Sorry, it's not. 4654 was written 11 years ago. Tiles and pedestals was not widespread, and unfortunately, the committee members didn't think about that. They probably would have written in at the level of primary drainage or something, but they didn't. They wrote finished floor level. So your options are get an upturn or put a strip drain here. We're not doing either of those things. Not compliant with GTS. Simple. What are we doing instead? Well, the idea is, and we're focusing very much on the door here, this is a watershedding diagram, theoretical modeling. It's one method of justifying how things work. Instead, we're counting on the gap between these pavers to shed and drain water, right? And a lot of people say, and fairly so, I love this design. I'm not saying it's a performance solution because I think it's bad, but it can go wrong, right? What if we did this and we had zero gap between each of these? They butted them up against each other. Now you have no drainage, right? So what's the right amount of drainage? Is 1 millimeter enough? 2 millimeters? 3 millimeters? 4? You go up and you start getting the area of maybe this will work. How do you actually know? Performance solution, right? We're saying that we're not putting a strip drain here. Our tiles and pedestals are going to do the drainage. We'll check how much hydraulic capacity there is between those tiles and pedestals, and we justify it that way. There's a few other things to consider about this, but that's effectively it. Really simple performance solution. You're trading one thing with another that's going to perform equivalently. Oh, next one is windows in showers. Architects love these lately. Pretty cool. I guess some people like having a view or giving their neighbours a view while they're in the shower. What's the problem? We're getting a lot of water applied to this, right? And our internal wet area standard certainly doesn't say anything about showers, so there's nothing there offered. But what it also does say is that you have to have a continuous membrane applied to a substrate. So unless we're going to call this window water-resistant substrate and put membrane over it, we're definitely not complying with GTS. So what are the important things to consider? For anyone that's familiar, we have two performance requirements for our internal wet areas, and to put it simplistically, first one is you must contain water in your wet area and move it to the drain. Pretty obvious. Second one is we don't allow any water into concealed space. So concealed space would be your wall cavity where your stud frame is there, right? So our primary concern here is this detail, whether we're going to let any water into our wall cavity. And I've seen these built terribly wrong. Like this membrane here is turned out onto this window frame. It's not going to last. First of all, your tiler's probably just going to cut it back because you don't want to see the membrane, or someone's going to cut it back because you don't want to see the membrane. You've got a very weak connection onto your window frame. And the other problem is you're then thinking about, well, where's our sarking run here? And as a quick solution for this, what you want to do, if you're ever in this, the key to all of it is to make sure water doesn't enter your cavity. How do you do that? You connect your internal waterproofing to your external weatherproofing. If you can use a water stop angle as a way of connecting those two elements together, you're going to have a continuous system, right? If water did try to get out around that frame, it's just going to run outside. No harm, no foul. So that's one example. We've got one more example here. I'll be pretty quick on this one. Concrete deck over plant rooms. I just chucked this in here because it was one we looked at recently. Our external waterproofing standard requires a waterproof membrane tested to AS 4654.1. Is it possible to make concrete waterproof? Yeah, it is. It is. It's not easy. There are a lot of things to consider. Degree of crack control, reinforcing, hydraulics, how fast we move our water to the drains is going to reduce risk, all of those sort of things. So is it possible to delete your waterproofing from this design, even though you've got areas that need to be protected below? Yeah, it definitely is. You just need to demonstrate that you've thought of everything. And there are quite a few things to consider, but it is possible. Our waterproof concrete structure is then our membrane system, effectively. And I believe that's it for this section. Cool. How are we going for time? Very good, thank you. So this is going to be a little bit of a change of pace. I will talk to this while I pour a drink of water. 15, okay. Got to be a little bit quick. So all of these models that you see up here, these are concept models. Normally our architect wants to dazzle their potential client with some nice concept models of what they're going to do. These can be rendered. They're quite time consuming to put the shapes in, render the lighting, all of those sort of things. Sorry. They normally are. All of these were created using generative AI. Probably took around 15 seconds to create each one. Significant reduction in workload there for our architects and designers. So before I talk more about this, we actually need to cover off what is generative AI relating to photos. So it's actually called image diffusion. I've got a few popular ones up here. You guys have probably seen this. We've got the Pope and the Puffer jacket on the left-hand side there. Obviously never happened. This was created using a model called Stable Diffusion, very famous now. Also have an astronaut riding a horse, equally improbable scenario, though it does look like a real photo. Bottom right, we have Harry Potter in the gym, also known as Harry Spotter. And then finally, we have a cat, because there will always be more cats in the internet. So how does this work? It works using a system called an adversarial network, generative adversarial network, or a GAN. And effectively what it does is goes through a series of steps where there's effectively two intelligences. One generates an image, and the other one says, this looks more or less like, or this doesn't look like the prompt we've been given. In this case, the prompt was a fantasy castle. So you go through each of these steps. First one proposes a new iteration. It builds on the previous one. The second AI says, no, that's not what this should look like, based on the billions of images that have been put into my memory as the AI. So you go through this incremental step process, and it refines it, and it gets better until you get something that's pretty decent on the bottom right. Now, this is all still quite new technology, and you can see that while this at face value does look like a nice fantasy style castle, if we were able to zoom in up here, you could see that a lot of these structures are completely unbuildable. The roof lines don't line up. It doesn't make a lot of sense. But this is new technology, right? It doesn't get it 100%, but it's still pretty impressive. So how do we apply that to design? So here's a sketch. I did this up in, 30 seconds or so. And I said, this is the concept I have. And I applied a prompt to it. Let's see what that prompt is. This is what we want this to look like. When a beautiful nature's meets architecture concept of residential house by Mark Ingles Group, famous architect apparently. High detail, glass railings, outdoor staircase, terraces, roof garden, cinematic photography, high resolution, right? Let's see what we got back. It was one of my first attempts, but that's pretty cool. All in 15 seconds after I put it in the prompt. It takes about 15 seconds to go through, 40 or 50 steps to reach this point. So you see we've got our glass here. Externally, we've got a railing, a balustrade up the top like we asked for. Let's look at a few more. Another one, slightly different lighting. And then all I have to do is press generate again, because there is a degree of randomness with all of this. It's still in line with our original prompt, but it's totally different at the same time. This one obviously a little bit off. This high concrete wall here, I don't think that's what the architect had in mind, so we go to the next one, and we've got a snowscape here. Pretty awesome. Night scene. Great, let's do the same thing for our internal space here. What are we applying for our prompt? Type, type, type. So we've got concrete flooring, wooden dining table, garden view, and windows with sunlight from the windows and large glass. Remember all of those things? Let's see how well we did. Pretty good. I think we're hitting all the key words there. But again, you'll see some things that look maybe not too buildable and whatnot. Let's zoom in on some here. You can see our chair legs don't really make sense. Our door looks really weird. Our bench top here looks really strange. That's right. So maybe it's not so far off the truth, actually. Okay, we're going to run through a few more here. We've done a sketch. We want to show the whole external of the house. I'll run through this pretty quickly. Actually, I do want to show something. You've got to be very careful with the way you write these prompts. So we've got a house inside a forest full of trees and plants. What do they give us? We actually have a house that is in fact full of trees and plants on the inside there. So cool. I'll run through these pretty quickly just to make up some time, but you can just see the variation in the prompt we're applying to our sketch. We've got something, these don't look very habitable. I think I was in a bit of a rush with these ones, but very cool for inspiration. Another one, we've got a cuboid design with a lot of glass and whatnot. This is really just to show you the variety that you can achieve with these things. And that's it for that section. Now, one thing I would have liked to include in here before I moved on, those are concept designs, right? And the way that these are achieved is by feeding a model large amounts of information, large amounts of renders, right? With a million, a billion, the more parameters you have, the better the outcome's going to be. What if we wanted to do floor plans or section details? Process is exactly the same, right? You feed it enough information on what looks right, even feed it things that are wrong, but tell it why it's wrong, and it'll be able to do the same thing. We'll be able to do waterproofing section detail of a brick veneer wall with stud frame, flashing, waterproofing upturn interface with flashing. That's very doable, and I didn't include anything in on that, but I should have, so just use your imagination. So, spatial design. VR headset's been around for a little while. How is this relevant to us? Well, this sort of 3D render, right? Again, it's the end consumer and a bit of razzle dazzle here. To do this would have been significantly time consuming. All of these things measured and rendered and put in place and effectively handcrafted, right? We've got our participant here, presumably buying one of these apartments from the showroom. He's having a walk around. In this space, we'll have a little bit of a thing soon where it swaps out. Yep, we're looking at a different package, different finishing package in there. All pretty cool. These take ages to prepare. What if we could use our generative AI to do this a lot quicker? By applying image diffusion into spatial design. So for some reason we're not getting any volume out here. I didn't plug it in. This is not the sound guy's fault at all, it is mine. External headphones. So that was probably a little bit to take in. Love that music, by the way. Let's just run through what we saw up there. Step 1, 3D space sketch. You can see, very rough, to be honest. I know a lot of primary school kids that could do better than that, but it serves the purpose. So we use this in 3D space to set the framework that we are going to apply our AI diffusion model to. So what have we done? What's our prompt look like? For that sketch, we applied a post-apocalyptic square with a ruined road, broken statue, fires burning, and smoke in the sky. If you didn't already see it, I can tell you that it hit all of those words, and it looks pretty great. Okay, we're going to do another one just to show that it wasn't a fluke. So this one we've got magnificent, the same actual sketch. Magnificent monumental square with brick wall, trees in line, statue holding a torch, and warm street lamps. Yep, there's our statue holding the torch. Excellent. And one more for my daughter. We have, well, it doesn't look like it's playing. Okay, Candy Square Wonderland with bright colors. Again, exact same framework, totally different imaging. Pretty cool demonstration. Doesn't do very well with the statue though on this one. We get a tree and a lamp, which I guess that was part of it. It was a torch. Okay, so that's it. Cool. You can imagine how this can be applied now to a VR space showing off. All we'd do is do a sketch of our apartment. We'd put in the prompt saying, modern minimalist apartment with blue curtains and whatever. I don't know. I'm not an interior designer. So where do we go from here? Now let's move from the design stage into construction stage. I think that's something you guys will be a little bit more interested in. A nice little video here. Digital twin is a word you've probably heard of recently for record keeping. This is effectively a dollhouse digital twin that's taken of a project in construction, snapshot of a point in time. Imagine you're responsible for a project for plant delivery, you're on the other side of the planet, you need to check that things are going to fit in place. Well, fortunately for this project, we've got a full digital twin taken that day. We're going to go in, we're going to measure that our plant or whatnot is able to fit into this space and we don't have to redesign it. So there we've just taken a measurement based on our on-site scan. It's 3.55 meters. We know everything's good to go for tomorrow. What's the problem with this type of technology? It takes a lot of effort. A lot of effort. Be someone walking around there all day, taking those scans, then they've got to go back, they've got to compile them, upload them, stitch them together. There is great technology that does this, but there's still a lot of manual effort into it. So that manual effort and the cost associated with it is what's stopping us from having fully remote inspections effectively. How do we overcome that?
3D laser scanning technology to capture and monitor site progress was integrated in the strategic plans developed by our Applied Research and Development Group.
This enables Spot to capture constant, quick, and consistent scans of construction sites. This precision monitoring tracks progress, also checking as-built versus as-designed models. Scanning and post-processing times have been reduced from weeks to a matter of days, while freeing up staff resources. Spot's remote control features greatly improve site visit safety and efficiency. Together with its ability to follow a pre-mapped route, Spot provides consistent repeated scans, navigates difficult terrain, and can access hard-to-reach areas on site.
This technology could be used to create four-dimensional models of our buildings, highlighting how they change over time. Combined with data from sensors that read environmental conditions and occupancy, we can create an intricate model of how people, furnishings, and environmental conditions interact. These four-dimensional models can become virtual collaboration spaces, available to people who cannot physically be in the same location.
Pretty cool. We don't have to do the surveying anymore. Dog takes the photos, comes back, plugs in somewhere, uploads them all automatically. Now, the thing I thought was really cool about that, you might have caught it where they said it's 4D modeling. fourth dimension being time, right? How many building inspectors that go out after completion of the structure, you're looking for an issue or whatnot, or anything, you look at something and you're like, what's the build-up of this wall here? Like, what's happening? I wish I could see inside. I don't want to do destructive demolition. You're trying to solve a problem for the client, get an outcome. Imagine being able to look back through the documents, have a digital twin of every day, every second day, third day. You just scroll through, peel back all the walls through time, see what was in there, see where your services are, see where your studs frame, all the structure is behind everything. Very useful, a lot of value in it, but it is an investment up front. Okay, next point. AI bots for access to information, right? Everyone would be familiar with ChatGPT and whatnot. Cool to talk to an AI and have it respond back to you. What's the real use of this? It's access to information, right? We don't want to go and sift through standards and try and find clause and whatnot. We're a natural language society. We want to be able to say, we want to talk to someone and say, hey, where's this clause that talks about X, right? Well, to that effect, I would like to introduce you guys to Aquila. She's actually live on our website at the moment. Feel free to have a go, have a talk to her. Aquila is an artificial intelligence that's been trained on currently limited information. We're just really focused on the waterproofing standards. So 3740-2021, 465, 4.1.2, 4858, BS 8102. We put a lot of that in there. So she's up there. Now, let's just see if we can have a quick conversation here. Refresh this. Okay. Again, our internet's not great here, but it seems to be working well enough, so let's go. Hi. Give her an easy one to start with. What is a pressure seal? Include source. Well, that did not work out. These are the risks of live demonstrations, I guess. We'll give it one more go. What is the difference? Okay. It's a bit more than we were looking for, but let's check out the veracity of what she's given us here. So, difference between enclosed and unenclosed showers. They both have distinct characteristics and requirements. Here's the difference between the two. An enclosed shower refers to a shower that's fully enclosed by a shower screen or panel. The shower screen or panels are designed to be installed to prevent the spread of water from the shower to other areas. The purpose of the enclosed shower is to contain water. Doubling up a little bit there, but still very good points. Enclosed showers are typically found in bathrooms with water containment as a priority. That's completely correct. Shower screen may be frameless or fitted with seals and deflectors, so that's completely true as well. A lot of people maybe aren't aware of that. You don't need to have a huge frame around your shower to call it an enclosed shower. You can have a frameless shower screen, but you have to have deflector seals around the outside to prevent the escape of water, then you can call it enclosed. Just jumping down to unenclosed. Unenclosed, on the other hand, do not have a fully enclosed shower area. They may have different configurations, such as shower curtain, shower over bath. Honestly, this is a better response than if you had to ask me what this difference was. But I think you get the point. Just because we're on time a little bit, I won't do any more than this. But she is available to discuss anything you might want to around waterproofing, of course, on the Waterproofing Integrity website. So, what's the next step up from that? Sitting down, typing in a computer, to get your answers. That's not bad, pretty useful, probably a lot easier way to find the clause than whatever you're currently doing. What's even better than that? We want to have someone that's always available, I don't know, on our phone, an app where you can just talk like a normal person. Well, to that effect, let me introduce you guys to Annie. I'm actually presenting to a room full of people at the moment, and I want to show off some of the cool things you can do.
Group of construction industry professionals today. It's a bit nerve-wracking, but I'm excited. Any tips on how to make a good impression?
I don't know, I guess you just got to be on point. And maybe let's just talk about some things. I've got a new project starting up, and it has CLT timber in it as the structure. Can you tell me a little bit more about this? Because I haven't worked with it before.
Oh, CLT timber. That's really interesting. CLT stands for cross-laminated timber, and it's a type of engineered wood product made by stacking layers of lumber in alternating directions and bonding them together with adhesive. It's becoming quite popular in construction because of its strength, sustainability, and versatility. CLT offers a lot of benefits. It's lightweight yet incredibly strong, which makes it great for building structures. It's also fire resistant and has excellent thermal insulation properties. Plus, it's a renewable resource, so it's a more sustainable option compared to traditional building materials.
I'm just going to interrupt you, Annie. We're actually short on time, so I'll just get you to keep your responses down to about 10 to 15 seconds. On that note, how does CLT compare to reinforced concrete?
Sure thing, David. CLT and reinforced concrete have different characteristics. CLT is lighter, faster to install, and has excellent thermal properties. Reinforced concrete, on the other hand, offers higher strength and durability. Both have their advantages, so it depends on the specific project requirements and design considerations. Does that help?
Yeah, it does. So I'm actually, considering it's timber, and I think it'd be susceptible to moisture, I'm pretty worried about the waterproofing. Do you have any recommendations on how I should select the waterproofing system for this project?
Absolutely, David. When it comes to selecting a waterproofing system for CLT, there are a few key criteria to consider. First, you will want to ensure that the system is specifically designed for wood and compatible with CLT. Look for products that provide long-lasting protection against moisture and have been tested and approved for use with CLT. Secondly, consider the specific requirements of your project. Factors such as the building's location, climate, and exposure to moisture will play a role in determining the appropriate waterproofing system. Consult with a waterproofing specialist or manufacturer to get their expert advice on the best solution for your specific needs. Lastly, make sure the waterproofing system complies with the relevant building codes and standards in your area. In Australia, for example, you'll need to comply with the National Construction Code NCC requirements for waterproofing.
Hey Annie,
remember,
on that
it's always
note,
a good idea to consult
what's
with
the external
professionals.
waterproofing standard under the NCC in Australia?
Hey there, David. Great question. The National Construction Code NCC in Australia has specific requirements for waterproofing. The relevant section is Part 3.81, which covers waterproofing of wet areas in buildings. It outlines the standards and guidelines for waterproofing in bathrooms,
Hey Annie,
laundry,
I'm
and
actually
other areas.
interested in what is the waterproofing standard for external areas?
Hey there, David. When it comes to waterproofing external areas in Australia, the National Construction Code NCC provides guidelines under Part 3.82. This section specifically addresses the waterproofing of external balconies, decks, and other outdoor areas. The NCC sets out
Hey Annie,
requirements
I'm
for
going
the
to have
design.
to interrupt you. I don't think that one was quite correct, so it looks like everyone in the room is still safe in their jobs for today. Why don't we wrap up by just saying a goodbye and thank you to everyone for attending.
Oops, my bad. Sorry for the incorrect information. But hey, safety first, right? I'm glad everyone's jobs are safe for today. All right, let's wrap it up with a big thank you to everyone in the room for attending. Your presence and participation are greatly appreciated. I hope you found the information useful and engaging. If you have any further questions or need assistance in the future, don't hesitate to reach out.
Thanks, Annie. Pretty cool, right, guys? Okay, I know we're almost at the end now, and I'm sure I'm almost out of time, but we do have just one more note to leave you on, and it's not that video. This is a advertising campaign put up by a recruitment or labour hire company in Ireland, I believe. It's obviously a play on ChatGPT being very good at finishing sentences, but not being very good at finishing buildings. So, I don't like complacency. And this is why. Well done, what a show off. If I had an apprentice with half that pep, I would consider myself very lucky. Okay, so I'm going to leave you with this quote. You don't want to abandon the skills and experience you have gained, but to find a new way to apply them. Your eye is on the future, not on the past. Often such creative readjustments lead to a superior path for us. We are shaken out of our complacency and forced to reassess where we are headed. I think that's a nice way to wrap up the opportunities that we have in the future, and I hope you guys are a little bit more excited about it. Thank you.